Okay, so for lab today, we have a function generator, an oscilloscope, and a circuit board. And in this circuit board, I have a 10 microfarad capacitor, a 68 ohm resistor, and a 5 millihenry inductor. Now looking at the function generator, you can see that we have it set to a sine wave. And because it's set to a sine wave, it will create a sine wave on the oscilloscope. You can also see that there are different increments on the function generator. And as I change the frequency over here, you can see that it changes the value on the oscilloscope. For example, this is at about 12 hertz. So it creates a wave over there. But as I change it again to go in increments of 100, let's say that I change it to around as high as it'll go on this setting. We have around 200. You can see that it creates a different wave over here. Then going up to 1,000, you can see that it creates, we're about at 2,000 now, you can see that it creates a different wave. So to actually collect your data, what you'll need to do is you need to try multiple frequencies over here. And as you change each frequency, you'll go over here to the oscilloscope, and you can see that the waves are different on channel 1 and channel 2. Channel 1 from the function generator shows your applied voltage, and channel 2 shows your voltage across the resistor. So as you change your frequency in the function generator, you come over here to the oscilloscope on channel 2, you change the position of the wave so that it's lined up with one of the main divisions on the oscilloscope. For example, the thicker lines there. Line it up on one of the divisions, and then you count from the bottom of the wave to the top of the wave. So for example, on this frequency, we have 1, 2, 3, and then you have 3.4 divisions. Because we have 3.4 divisions, to find the actual voltage on this channel, what we will need to do is to multiply it by the time per division. And I currently have the time per division set at 0.5. So you would take 3.4 and multiply it by 0.5 to get your voltage. And then you would just repeat the process for different frequencies and graph your data to try to find your resonant frequency, which would be the highest point on your graph.